Okay, so this is part two of our series on UFO physics and quantum physics. And we discussed in the first episode the 2004 Nimitz encounter and noticed certain properties of the UFO in that encounter with two professional pilots on F-18, I believe they were F-18s. And then we showed you a 2013 Homeland Security video from Aguadillo, Puerto Rico, that showed a object similar to a Tic Tac, but more circular and not as elongated, apparently. But it had no visible means of propulsion, had also no airfoils, and yet it was flying at 90 plus miles per hour and up over 100 miles per hour. And then goes into the water a couple times, and then on the second time comes out and splits into two equal looking parts. And so the speculation I threw out there, that's all crazy. Those two encounters are crazy, yet professionals are involved, and there's video of the second encounter. So it's not crazy to come up with crazy solutions to that. So in other words, it may sound outlandish, but you need something to explain something that doesn't obey the physics in our realm. And what can explain that is that we actually know of something that doesn't obey the physical laws of our realm, but obeys the quantum physical properties of the quantum world, which turns out to have laws contrary to our physics in the quote real world. And anyway, so we're gonna test this, and we're gonna take a look at a few things. Let me just explain something. We'll show you a short video later on Neil deGrasse Tyson that he explains an extra dimension helps explain quantum mechanical effects in our world. And so when we look at our universe, we're in a four-dimensional world, and he'll show you a two-dimensional world that an ant lives in. And so they are not really aware of the idea of height because they live in a flat universe. So we are living potentially in the same kind of universe. And as a result, we are not aware of certain quantum physical processes that may be going on around us, but are actually in the other dimensions that are right near us, but we can't see due to their existence. And scientists actually had concluded in the Big Bang that the universe started with a lot more dimensions than we have now, and then folded further, smaller and smaller, until we see what looks like a four-dimensional universe to us: height, width, depth, and space. So, and so what caught my eye is when I saw that Aguadillo UFO splitting in two, that really came to my mind is the chlorophyll molecule. And it works on quantum physics. So when you put together what Neil deGrasse Tyson is saying with the chlorophyll molecule, and then you put it together with the splitting of the Aguadillo UFO, it isn't as crazy as it first sounds. So let me explain the chlorophyll molecule. So we can study these things separately for their own value, and they're interesting in and of themselves, but then we'll see there's something that may actually help answer what happened in Aguadillo, Puerto Rico in 2013. So a chlorophyll molecule can extract from a single photon of light from the sun 95% plus of its energy, compared to what we only can get 15 to 20% with our standard conversion of in solar panels. Although they're doing better with certain experimental material, but it's still only around 50%. Now, what this means is the origin of chlorophyll molecule becomes essential to find out how did this come into existence. So could this have just evolved by a happenstance of a lightning strike or some series of effects within Earth? Is there likelihood that a quantum computer, if this is operating on that, is really operating on something that is caused by an accident? And that's an important question, because it turns out the chlorophyll molecule, whatever it is the key to life. Because without it, we would never have gotten out of where we were. And I don't know if we're going to get into this in this detail, but there was an anaerobic period of life where there was no oxygen on Earth being produced by anything, and it was instead the other way around. Oxygen would have been poisonous to life, and it was only the development of chlorophyll that changed that. We're now producing oxygen from sunlight would be okay and productive that would create oxygen that other beings could come into existence that would use oxygen, which includes ourselves. So the universe was completely the opposite. And then starting around 2.5 billion years ago, chlorophyll comes into existence, and that's when everything reverses, and now we're creating oxygen. And all right, so let's just take a look here. So here's a statistic on photovoltaic energy fact sheet. Currently, this is 2022. And it says, though most commercial panels have efficiencies from 15 to 20%, that is converting a photon of light into energy for your use in your home, researchers have developed recently PV cells with efficiencies approaching 50%. Still experimental, but still, it's not anywhere close to 95%, right? All right, so let's watch a short video, 3 minutes, I think, from Neil deGrasse Tyson. He's going to explain how dimensions, a second dimension or more dimensions than we're familiar with, would appear to a person who doesn't have access to that dimension, and how that is how the quantum physical world can operate right in our midst, but we can't perceive it. We can see its effects, but we can't enter into that dimension and exist in it, but we can see the effects of it in our universe. So let's listen to Mr. Tyson.
I'm at my desk, and the desk is a surface, okay? And I start putting pages down on the desk. I'm tiling them on the desk. And then I run out of room. I have exhausted the 2 dimensions of the surface of my desk. We have ways of accommodating this problem. And so we have page organizers that go upwards. So now when I don't have any more surface area of the desk, I can enter a 3rd dimension and put pages there. If you are an ant embedded in this 2-dimensional world of the surface of my desk, and you fill up the desk with these sheets of paper, the ant will say, there is no more room. And I say, yes, there is. Watch me. And I take a piece of paper off the desk, put it in the page organizer, and according to the ant that's embedded in the 2 dimensions, that page disappeared. It disappeared into a dimension that ant does not have access to. What a brilliant invention this is. You can put practically an unlimited number of pages, far more pages above the desk than on the desk. So access to a 3rd dimension is an extraordinarily useful storage device. Watch what happens next. I now have my 3-dimensional room, and I'm filling it with boxes. Now I've run out of space to put the boxes. But now a 4-dimensional alien looks at us and says, I got this. Just move it into the 4th dimension. What are you talking about? And the alien comes in, reaches in, takes one of the boxes, and then the box disappears. Disappears. It went into a 4th dimension. So imagine a new storage system where you just go to Home Depot and buy a door. And that door is your portal to a 4th dimension. You open the door, put your boxes, close the door, you look on the other side of the door, there's nothing there. So this is what's going on when you have access to higher dimensions. Now, there are things that happen in quantum physics that kind of defy our sensibilities. Like particles pop in and out of existence. They defy any rational attempt to understand it. Particles can be entangled with one another. A particle can be here, and there's a barrier, and it can spontaneously show up on the other side of the barrier at faster than the speed of light. All of this is just mysterious. So, who is to say that some of the mysterious things we are describing accurately, but don't otherwise make sense in a higher dimension? And these are just the manifestations of higher dimensional phenomena in our world. And that's an aspect of what these higher dimensional physicists are trying to establish.
Okay, so next, let's take a look at life on Earth that it depends upon the existence of a quantum computer operating in plants, although it stunned the scientists initially to find this, and they did everything they could to try to resist the evidence, but it has been invariably confirmed. And this is a recent video, which does an explanation to laypersons, but by people who are qualified to do so. So let's take a listen. It's a few minutes, but it's well worth the surprise of learning about something that is stunning, absolutely stunning in science.
Are there biological processes which need quantum mechanics to work? Now, this question is surprising for a couple of reasons. Quantum processes generally need very specific conditions to work. When physicists explore quantum effects, they work in pristine conditions, usually at temperatures of near absolute zero, with very expensive equipment, in complete isolation. So it seems odd that these same processes take place in the hot, wet, messy world of life. But experiments over the past decade have shown mounting evidence that this is, in fact, the case. Quantum biology is also interesting because it brings together physicists and biologists. A friend of mine, Pat Kelly, who runs the biology channel called Corporis, actually came to me with this idea. Together, we've crafted a 3-part mini-series which explores different instances of quantum biology. This first episode is about how plants may use quantum mechanics to perform perhaps the most important biological process on Earth, photosynthesis. On Pat's channel, we talk about how the engines that run our bodies, enzymes, may use a process called quantum tunneling. And finally, in the third episode, we talk about my favorite phenomenon, how some birds may use quantum entanglement to navigate the globe. So then, let's get started. How some plants may use quantum mechanics. The story starts in April 2007, where a group of MIT physicists were sharing science articles they'd found that week. One of the articles was suggesting that plants were mini quantum computers. The group exploded into laughter. The world's brightest minds had been trying to create a quantum computer for decades, and now it was being suggested that some dumb plant had outsmarted them. But as we'll soon see, they were foolish to laugh. First, let's talk about why someone would even make that claim. Plants as quantum computers, it does sound a bit far-fetched. Well, to understand this, we first need to understand a very old puzzle in biology. Why is photosynthesis so efficient? Pat can explain this much better than I can, so I'm going to let him handle it.
Life on Earth is only possible because of photosynthesis. You've heard of this phenomenon before. It's the synthesis of energy out of light, or photons. Trees do it, green algae do it, all kinds of plants do it all the time to produce over 15,000 tons of biomass every second. And even on such a big scale, photosynthesis comes down to just a chemical reaction. A plant or green algae takes carbon dioxide, water, and sunlight and turns those ingredients into sugar, oxygen, and usable energy for the organism itself. Sunlight, along with the whole process of photosynthesis, happens in an organelle within plant cells called chloroplasts. Inside the chloroplast are stacks of discs called thylakoids that are filled with little green pigments called chlorophyll. To understand how sunlight goes from a photon to usable energy, we need a little background on the chemistry of chlorophyll. These molecules have a long carbon and oxygen backbone, with a big grid of carbon and nitrogen surrounding a lone magnesium atom. This makes it so magnesium has a single electron in its outermost layer that's just barely hanging in there. So when a photon comes into the thylakoid, its energy knocks that electron off the magnesium. Here's where things get a little abstract. Usually we'd think of that magnesium ion, as a whole, as positively charged. It just lost an electron. But for all this to make sense, we need to reframe it a little bit. Think of it more like a neutral magnesium, a negative electron, and a positively charged hole where the electron used to be. This is called an exciton, and it can store energy. Those negative and positive poles make it work like a battery. But in order to make energy out of sunlight, the plant needs to get that exciton to a reaction center for a process called charge separation. This involves taking the electron from magnesium and transferring it to some nearby molecule so it can create a stable molecule. From there, the chemical process of photosynthesis can happen. But transferring that exciton is the hard part. Chloroplast can transfer energy from chlorophyll to chlorophyll until it gets to a reaction center, but that might be really far away. Plus, chlorophyll are packed together super densely, so how does the exciton know which way to go? For years, we thought it randomly stepped from molecule to molecule until it landed at a reaction center, but if that were the case, the excitons were more likely to get lost than to perform photosynthesis. And that was kind of a problem, because in the real world, photosynthesis happens with nearly 100% efficiency. Almost 0 electrons ever get lost. That's more efficient than any human technology we've ever come up with. Plus, classical chemistry couldn't explain how such an efficient process was possible.
This is a long-standing puzzle in biology, and the article that the MIT physicists were all laughing at was suggesting that plants use quantum mechanical effects to get around this. See, one of the main ideas in quantum mechanics is called superposition, and it's the idea that a particle can be in more than one place at a time. In the macroscopic world we're accustomed to, if something is in one spot, it definitely can't be in any other spot. But in the quantum world, things aren't so straightforward. A single particle can simultaneously exist in many different places with different probabilities. It's kind of like if you have a hedgehog in a box and you have to guess where it is. You might say there's a 70% chance it's where the food is, a 20% chance it's on the bed, and a 10% chance it's on the treadmill. These probabilities represent the likelihood of finding the hedgehog when you take a look. But the thing is, the hedgehog isn't really in all of these places. It's only in one. You just don't know which. But quantum particles are different. Before they're measured, they really are in all places at once with different probabilities. We can view these probabilities as a spread out wave. At every point in space, there's a different probability of finding the particle there. An important point is this probability wave only remains intact before it's detected. As soon as it's measured, it collapses into a single particle at one location. Yeah, there's a reason quantum mechanics has a reputation for being weird. Now, this idea of being in many places at once can be extended to taking many paths at once. If a particle reaches a fork in the road, it doesn't need to choose. It can take both. If it's presented with many paths, it can take all of them, like a wave spreading out over space. This is exactly what the paper was proposing, that the exciton takes all possible paths to the reaction center, and that's how it gets there so quickly. This explanation actually kind of makes sense when you think about it. So why were all the quantum physicists laughing their heads off? Well, the biggest enemy of all quantum processes is something called decoherence. Remember how we talked about how the superposition only lasts until a particle is measured? Well, in quantum talk, measured doesn't mean the same thing that it means in everyday language. Here, measured means when this wave particle comes into contact with anything else, like another particle, a molecule, anything. When it's in this wave state, it's said to be in a state of coherence. When it's broken or measured, this is decoherence. Decoherence is the reason physicists need to work in such specific conditions when they're dealing with quantum mechanical effects. In the macroscopic world we're used to, there are so many particles and molecules bouncing around, so much jostling and wiggling due to the heat, that coherence doesn't last long enough to be detected. This is why we don't see quantum mechanical effects in our day-to-day lives. It's also one of the main struggles with the creation of quantum computers. Physicists come up with all kinds of clever and expensive ways to shield their precious particles from the evils of the outside world, cooling them to near absolute zero temperatures and attempting to keep them in complete isolation. But so far, nothing has worked to keep decoherence at bay. And now this paper was suggesting that plants could ward off decoherence at normal temperatures and conditions? It didn't make sense. The MIT physicists sent one of their members, Seth Lloyd, to investigate this claim. What he came back with surprised everyone. Let's take a look at this paper which caused such a stir. An experiment was performed at the University of California, Berkeley, using a technique with the very impressive name of two-dimensional Fourier transform electron spectroscopy. The research team was able to probe into the inner structure of a photosynthetic complex. They fired 3 successive pulses of laser light into it, which generated a light signal which was then picked up by a detector. If there really was coherence among the excitons, they should be able to see interference between the different pathways, a so-called quantum beat. The leading author on the paper, Greg Engel, spent the entire night stitching together the data and found exactly what he was looking for. A rising and falling signal, like the interference pattern produced when waves interfere. In other words, this quantum beat showed that the exciton wasn't taking a single route through the chlorophyll maze, but was following multiple routes simultaneously. This was a huge shock to the scientific community. The MIT physicists were forced to admit that they may have laughed too soon. Numerous experiments have been performed since then, confirming this result. However, the story is far from over. Although this quantum beat keeps showing up, there's still debate over how to interpret it. Some experts in the field think that the beats are caused by molecular vibrations, not coherence. Others think the observed coherence was too small in amplitude to have originated in excitons, and then there are others who think that this quantum beat is in fact direct evidence for quantum biological processes. Let's just say there are mixed vibes. Research is still going on to understand how photosynthesis is so efficient, and may lead to insights to create quantum computers and other technologies. Quantum biology is an amazing area of research, rich with possibilities. This video was about the biological processes that plants use, but what about the processes that govern our own bodies?
Now, I want to illustrate something before we go too far into this, is that science actually stumbled across this evidence in 1801, and it involved an English physicist, Thomas Young, and he was the first one to find superposition. And superposition, which you saw in that video was discussed, is the ability of a quantum system to be in multiple states at the same time until it is measured. And so a quantum system is only actually proven by the fact it's violating the laws of the physical world. So we call it the quantum world. It's just a nice way of separating them out logically. Because the concept is difficult to understand, the essential principle of quantum mechanics is often illustrated by an experiment carried out in 1801 by the English physicist Thomas Young. Young did a double slit experiment. It was intended to prove that light consists of waves. That's all he was trying to prove. He didn't know what he was going to prove. Today, experiment is used to help people understand the way that electrons can act like waves and create interference patterns. But it's more than that. It's a way of showing superposition. For this experiment, a beam of light is aimed at a barrier with two vertical slits. The light passes through the slits, and the resulting pattern is recorded on a photographic plate. So it's simple science, right? You'd think it's simple science. When one slit is covered, the pattern is what would be expected. A single line of light aligned with whichever slit is open, right? So that's just mechanical, simple mechanics. Intuitively, one would expect that if both slits are open, the pattern of light will reflect two lines of light aligned with the slits. In other words, if one slit being closed creates one line of sight, and we can see that physical effect on a photoplate, then two slits open should be the same thing. It should be two direct lines of sight to two ultimate ends, right? So it's just logic, pure logic. In fact, what happens is that the photographic plate separates into multiple lines of lightness and darkness in varying degrees. This is not expected. What is being illustrated by this result is that interference is taking place between the waves going through the slits. So as the light goes through each slit, they are then interfering is the way they explained it. But it seems that there's a confluence or a coherence between each a beam of light going through each of the slits, so that there's some effect on each other, which you wouldn't expect it to have a behavior, right? It's just light, it's just physics, right? But it's behaving. It has a behavior. So it should be two non-crossing trajectories, but that's not what we see end up happening. Each photon not only goes through both slits, it simultaneously takes every possible trajectory en route to the photographic plate. So because now there's two lines of sight going through, instead of it taking its direct line of sight, standard physics, it starts taking every possible direction it can to get to the other side to where the plate is. And this is a remarkable effect of where is this happening from? Where is this coming from? It's not our physics of our world. And we can see that by keeping the one slit closed, we can see what the physics of our world operates. But when there's two light beams, it behaves differently and doesn't follow the normal physics of our world. So what is it accessing to do this? Okay. In order to see how this might possibly occur, other experiments have focused on tracking the paths of individual photons. Surprisingly, the measurement in some way disrupts the photons' trajectories. So we found out that actually trying to peek at it and look at it, hey, let's look at the photons, how they're moving, that kind of messes up the experiment. It won't work when we're measuring it. So the weirdness is the observer, just by observing and measuring what's happening, can actually affect what's going on. This is like out of a movie. It doesn't make sense. Well, how can the observer affect the outcome? It's just we're the observer. In every other physical experiment in the world, the observer is just simply measuring and doesn't change anything. But in this world, measuring changes the outcome. The results of the experiment become what would be predicted by classical physics. So now by interfering, by putting our measuring sticks on it, now we find two bright lines on the photographic plate. So what did we do? If we keep our hands off it and don't try to measure it, it comes out with, quote, interference. It blends and it finds every direction possible to get to its outcome. But if we're there peeking at it and trying to figure it out, it goes back to what we would consider normal physics, two bright lines hitting a photographic plate, each aligned with the slits in the barrier. So we actually affected the experiment by trying to measure the experiment. Bizarre, huh? This has led scientists to conclude that superposition cannot be directly observed. One can only observe the resulting consequence, interference. In other words, if we try to observe it while it's happening, we will screw it up. Now explain that in the real universe. But that's proven over and over again. And computing, the concept of superposition has important implications for the way information will be processed and stored in the future. For example, today's classical computer process information in bits of 1 or 0, similar to a light switch being turned on and off. The quantum supercomputers of tomorrow, however, will process information as qubits, 1, 0, or a superposition of the two states. In other words, you can have in the same qubit multiple states, so it will appear to be in two places at once, or frankly, a lot more places than once, but they're not trying to get their hopes up. We can't do what plants do, and they have it at numerous superpositions at numerous places simultaneously to absorb all the energy from a single photon. But anyway, that gives you an idea where superposition comes from, and the curious fact that you can't measure it. And if you you can prove its effects, but the minute you try to measure it as it's happening, you screw it up, and it goes back to normal physics. Isn't that interesting? So I'm just telling you, this is a weird area of science. Very strange. All right, so I'll let you go in in a minute. We want to follow up a little bit further on this article from October 2022. Plants use quantum physics to survive. Just want to go over some of the details that it has in this article. Plants are able to harvest as much as 95% of the sunlight they soak up, instantly converting this solar energy into chemical energy in 1 million billionth of a second in a process called photosynthesis. I mean, this now, I want you to think about the speed at which this is happening. So remember when we watch these UFO machines moving at extremely high speeds, you have to realize this is going on in the chemical energy inside of a plant. I mean, 1 millionth billionth of a second, converting a photon of energy into 95% of it gets processed because of a superpositioning of the same photon over numerous receptor cells simultaneously absorbing all its energy. This is almost like out of a science fiction movie, and yet it's a quantum computer. It's not anything but that. It uses qubits is what it's doing. It's changing that one photon now exists as qubits over this whole thing. It's processing it just like a computer, but not like we're thinking, let's just at least have one qubit. It has many qubits, and that's how I was able to do it in what? 1 millionth billionth of a second, doing that to a photon of light. Unbelievable. The speed of this process is amazing. because it has a supercomputer, because it's operating just like we are trying to create. Or we have a laboratory that we're doing this with. Google has created a quantum computer, but it's very rudimentary. It's just trying to have a second qubit floating in space, simultaneously replicating itself. And so they've worked on it, and the second particle is always very, very close, and they're hoping to separate it further and further apart. And they have all these ideas of creating black holes, where it'll be some distance apart, and you can communicate at far distances between two particles that are separated by a lot more space, and therefore, with that processes, you'll be able to have quantum effects from one part of the Earth all the way on to the other side. So you could communicate instantaneously without any wires, without any computer cabling, from a laboratory in New Mexico all the way to somewhere in Europe, or instantaneously, because the quantum signal to send from one to the other, in the quantum world, which is this other sort of dimension. They don't they don't talk about it that much, but that's what they mean. And so it's just a bizarre thing, and they've proven experimentally recently, in the same article, same month, October 2022, they reviewed this. That's why I'm reading it, and I'm going, this is pretty interesting. So they just first experimentally proved that. So now they're getting on the cusp of turning this into a way of having an internet, of a quantum internet, working inside of this other field. But let's keep reading. The new science study on purple bacteria, which also uses photosynthesis, and so one of the earliest bacteria was purple bacteria, and this uses sulfur instead of other things to create, using a chlorophyll molecule inside of bacteria. So bacteria actually first, quote, evolved the chlorophyll molecule inside of a living animal-like thing. A bacteria is like an animal. It's a living, breathing animal. It's not like a plant. So, it has its own mind. It can travel things. Plants don't do that. Plants grow, and they're pretty static. So this evolved, supposedly, quote, evolved, and that's what I I I put a big question mark on. So the Earth was anaerobic, meaning there was no oxygen being produced by anything, and they were actually consuming whatever oxygen was on Earth through these animals, the anaerobics. Suddenly, the chlorophyll molecule enters Earth about 2.6 billion years ago, and then gradually, from that point until the present, it started creating oxygen through a process of photosynthesis, and that is what we're breathing. And had this never happened, we would have nothing to breathe, because it would never have been sufficient oxygen to maintain life. Okay, so let's read this. The new science study on purple bacteria, which also photosynthesizes, gives more support to the idea that plants use quantum mechanics to achieve this near perfect efficiency. A trick of quantum physics called coherence, the researchers suggest, helps the energy of the elementary particles of light, called photons, find the most efficient path to a plant's purple bacterium, so-called reaction center, where the light's energy fuels the reaction that produces carbohydrates. Really produces oxygen if you break it down further. On a physical system, coherence could be illustrated with a pair of pendulums that continuously transfer energy from one to the other, backward and forward, in a coherent cyclic mode. When a photon excites molecules inside a cell, the energy does not hop through the system, but follows different energy pathways at once. That's the whole thing. It's not a hopping. It's not a physical system. It's literally sending that photon at once to every receptor to be simultaneously operated upon, simultaneously searching for the most efficient way into the reaction center where the chemical reaction actually takes place. This is why it's 1/billionth. What is it? 1 million billionth of a second. This is going on with every photon of light, and it processes it out in super, super fast time. This is known as the quantum principle of superposition, as I said. So it's these particles are in every position at the same time. They travel simultaneously across every pathway. And again, but if you try to observe it and measure it, it'll stop. It's so that's one thing you just have to remember. It's just this special thing is we have to just let it do its thing. But if we try to measure it, it says, "You're watching me. I'm not going to do it. Stop watching me." So you have to just watch the effect of it. The supercomputer doesn't like being measured. It's just one of those things. And it showed you in that video that once you remember the cartoon videos, once you touch it to see, can I see how it's operating? No, no, no. Boom, it stops. It stops working. So it's just one of those weird things. Why is that? It's like nobody can figure that one out. So let's just finish up here on its summary of the quantum effects in nature. Coherence has been suspected and experimented with in living systems before when researchers fired and extremely short, intense laser pulses at multiple molecules of a photosynthetic organism, a purple bacterium called, I'm going to get it wrong, so let's try it out, Rhodopseudomonas acidophylla, that applies the exact same principles of light harvesting to survive as plants do. So this is why it's a good substitute for plants. It's a bacterium, though, with the identical photosynthetic processes operating in it. And then track the flow of energy through its system. Okay, and then it has a little article. And look at that. Twisted physics, 7 mind-blowing findings. So that'd be fun to read, wouldn't it? But let's keep going. The latest research, led by Nike van Ulst of the Institute of Photonic Sciences in Castelldefels, Spain, went a step further. Quote, previous studies have done experiments where they had millions of molecules in the same volume that they were measuring. Co-author of the new study, Richard Cogdell of the University of Glasgow, told Live Science, quote, the quantum effects could be seen, but they were rather weak, and we never knew whether it was because they are weak or because each of the individual molecules was slightly out of phase with each other, so they interfered in a way that you did not see the coherence of quantum behavior. For the new test, the scientists used purple bacteria once again, but this time shot laser flashes at a single molecule instead of using many molecules at once. The light harvesting complexes of the bacteria are arranged in a pattern of adjacent rings or molecules that make up the light harvesting complex. In the organisms, the rings pack together, but the researchers isolated the individual rings. Okay, and put them outside the bacterium on a surface. So now they just literally took out the machinery to observe this. So in its context, they were having problems with getting the results that this bacteria does this thing in an amazing time span, but they were somehow interfering with its ability to process because of the way they were looking at it. So they decided, hey, let's take it outside. Let's take the machinery outside of it and just take one small part of it and then examine how that operates. When a photon comes into contact with an isolated ring, like what we're showing you, like what they're doing, some of it gets emitted as fluorescence, a form of natural luminescence, which is essentially spontaneous transfer of energy from a high energy to a lower energy level. Now, here's what they found. The researchers noticed that the amount of fluorescence didn't stay constant. It kept rising and falling, quote, oscillating between the high state and low state, which is this coherent oscillation, said Cogdell. That isolation suggests that laser light was able to find the most efficient energy pathway to the reaction center almost instantaneously, interestingly. So now, having pulled out the machinery and letting it operate without its getting too close to the measuring, it was what they were doing previously and probably affecting it to be weak. Now they're going to get the super strong signal and it's almost instantaneous. So somehow they don't know yet really what's going on here, but they pull the machinery out in life, and now it has an instantaneous reaction, instantaneous processing, despite the highly variable conditions of the biological system. Okay, so okay, then quote: this sort of coherence have been seen in physical systems before, but only at very low temperature and very well-defined controlled conditions. So in other words, the only way they could do this themselves when they tried is they had to lower the temperatures very low, create a clean laboratory system, and then use very controlled conditions. But here they were doing it for the first time, just simply pull the machinery out of life and just look at that very isolated part of the machinery, and it worked. So this is a big step for them because they were having trouble measuring it. So when they try to measure it and put their finger on it, they screw up the effects. But here they pulled it out and somehow it's working. Greg Engel, a chemistry professor at the University of Chicago who was not involved in the study, told Live Science that the most exciting element of the research was, quote, pulling back the curtain and learning how photosynthetic energy transfer really works. Quote, the authors point us toward new design principles for controlling the flow of energy through molecular systems. So maybe we're going to figure out now how it pulls this trick off. At least we know the machinery can be isolated, and we can maybe what they're going to do is they're going to have to harvest plants the chlorophyll molecule, and then isolate it from other chlorophyll molecules and just try to do it one off at a time. But that way we can control it. Otherwise, life is just so variable, and you can't have your computer growing. It has to be static. So you have to actually have physical machinery that does exactly what the plant is doing, but you have to find a way that it's not alive, or otherwise it's going to get old and sick and need food. You want to find a way you can do this without having it actually being alive. All right. Once it is clear what factors affect the frequency of the occurrence and whether it is possible to vary it, the findings could lead to boosting the efficiency of the light harvesting process. So we can maybe learn something that we can apply to our own inferior, stupid, solar cells that we've been creating. Nothing compared to what this thing is doing, and it's a life form. It's a life form that just suddenly appears at 2.3 billion years, goes from a life which is completely anaerobic, doesn't use oxygen. I mean, what can I put it? It's an anaerobic world. It doesn't have oxygen. And now you're going to have an aerobic world which creates oxygen, which kills all the life that existed before. Do you realize that all the life that existed for the first billion years is going to be killed off by the life that comes up that's photosynthetic and is going to now produce oxygen, and that oxygen is poison to the life forms. And if you didn't know it, our life forms, the higher life forms, all have a way of combating the deadly effects. Oxygen is poisonous to our systems. Did you know that? So we have a system that counters the oxygen effects in our bloodstream and protects us. That's a whole nother complex thing. So higher life forms could not exist had we not had that process, which is like a countermeasure to chlorophyll inside of our own bodies. So that's a whole nother thing that we need to study. How did that come about? But the point is, this gives us a chance to actually make solar cells using the photosynthetic processes if we can harness it without having to have chlorophyll be alive in order to harvest from it. And so that's going to be the next step. And they're going to get there. But to do that, they're going to end up creating a supercomputer necessary to do what a life form does without any supercomputer at all in not even cold temperatures, but in normal temperatures. And so they're actually made the first step with this scientific discovery of doing the same process using a plant, using chemical things that don't have to stay inside of a living organism, just pulled it out, and it worked. It worked very well. And so that means we could possibly do that in our solar panels of the future. Okay. So anyway, now how does this explain anything? This explains the UFO potentially, because the UFO has potentially can be explained by superpositioning. So when it looks like it's replicating its parts coming out of the water, well, let's look at the video again, and I'm going to narrate it, and I want to comment on what we're seeing, and then see if it doesn't make more sense as we watch it. Okay, so here's the video from Puerto Rico, Homeland Security UFO video footage from aircraft shows mysterious UFO. So again, this is a government thermal camera that is just using heat. So it's sensing there's a heat in this object. It's trying to catch people who will be using ships offshore, planes, little planes as well, to bring in drugs into Puerto Rico. So it has so you can, makes sense that this video could be taken and be tracking the heat of this object. And so let's watch it again. Let me see if I can get this going here. It says here now do you see it disappears? It seems to be it's underwater. Now it's coming out a little bit. There it's out. And it's one object, not two. One object, one object, one object. It's circular, it's round. It's moving at 90 miles an hour to 110 miles an hour. And then it disappears. Seems in the water again. But you can almost see it underwater. And there it comes. It's back out. Right? Now it's going to go back down in the water. Its heat is still being picked up and tracked by the tracker. Now watch this. It's going to come out. Well, it appears to be one still, right? Still one object. Still being tracked. There it comes out again. There it is. Now, suddenly it's two pieces, seemingly the same size, and being tracked with similar heat. And they're totally distinct and not connected. You can see the heat signatures got picked up for both objects at one point. And now By the way, doesn't it look like the other object disappeared? It's no longer being tracked, but it was being tracked for a period of time. So what explains that, right? What happened to the other one? But it's gone. So the other one went back into the ocean, or did it refuse with the original object? See, this is mysterious. The more mysterious the more time you take to look at this video, the more mysterious it becomes. And so it's just tracked the heat to the it's trying to find it now, I think. It can't find it. All right. All right. So we're going to sign off now. I'm just going to throw in my 2 cents worth. So I think what we are going to find out in the future is that these indeed are aircraft that are in our same space, in our world, and they're in another dimension right near us, just like if we were ants and they are putting their hands, like we would put our hands into the world of an ant, and we see them suddenly, boom, and they can just disappear when they take their hand out of our world. And the reason they're able to accelerate at such high speeds is they are efficiently transferring, they're using photosynthesis themselves to immediately accelerate, just like we showed you the photosynthetic process can change a photon within 1 millionth, a billionth of a second into energy. So it's an instantaneous process, uses virtually has no propulsion itself. I mean, the plant doesn't have any fuel source other than the actual photon it takes in. So photosynthesis is so efficient, you don't need any external fuel. It fuels itself. It's so powerful. So, or a very minor amount of external fuel. So the bottom line is, photosynthesis may be the pathway forward in the future to make planes that can fly without using polluting and costing nothing, just using the photons of the sun. Same thing with cars. We just need to store the energy overnight, and we can eventually get to a world that will not depend on fossil fuels. And one thing I wanted to say this is, like, if we don't come up with a solution, people keep ignoring this, but fossil fuels will run out in about 100 to 200 years. And yes, we may find them further deeper down in the earth, but did we not know that fossil fuels are what? Fossil fuels are the fossils of the past, the dead flesh of animals that congealed into oil. So, it's a finite thing. It's not a mineral. It's a unless we know how to synthesize oil itself from life forms, we will need to find another solution. And the solution I'm suggesting is shown here in these videos, meaning these aircraft, these Tic Tacs or circular aircraft with no means of propulsion or ability to fly in any way we can see, are somehow operating using, I think, something akin to photosynthesis. And so they can operate with virtually no external energy force. I don't know how they're flying though. That's my mystery here. I have no explanation for how they can fly without airfoils. Okay, but again, if they're from another dimension, this may not be hard at all. It just looks hard in our dimension. It looks like a miracle, right? But from their dimension, it could be completely normal. Just like our hand going into the world of an ant will affect what the ant sees and thinks it's a miracle when our hand comes into their little universe and moves a piece of paper around. But that may be what's happening. It looks to us like a miracle, but from their dimension, it's not. So anyway, I hope that helps everybody. Goodbye. Take care. Ciao. Bye.